We're going to take a look at a video here dealing with checking, how to check equations, how to check expressions. Almost all students know how to check equations. We won't spend a killer amount of time on that, just give you a couple rules. And then we'll show you how to check expressions, something most of you have not been taught how to do. So checking equations with one solution, this is a piece of cake thing. If you have an equation, say like 3x plus 9 is equal to 36. And you solve this thing by subtracting 9 from both sides, dividing by 3, x is 9, and then you're going to check it. You plug the original, you check the answer always in the original equation, no matter what's going on. You go back to the original. 3 times 9 plus 9 is equal to 36. 27 plus 9 is 36. That's enough to know for sure that this thing's true. That's generally the format I want it in too. You should have your original equation written down, any work that needs to go on. You should have your answer circled, and then it should be plugged in. Some students put it below, some students put it over here. Doesn't matter to me which one it is. If you do put it below, circling the answer is important. So if you have one solution, you check it. What if there's more than one solution? What if, for example, I had x squared plus 3x minus 4 is equal to 0, and I go to solve this thing, and of course I'm trying to factor it, and I end up with plus 4 minus 1 is 4x minus 3x, so that works. So x plus 4 is equal to 0, so x is negative 4. X minus 1 is equal to 0, so x is 1. I end up with two solutions. X is negative 4 or 1. Again, I'm going to circle that, but there's more than one solution. There could be 2, there could be 50. What do you do if there's more than one solution? You're only expected to check one solution. So if you have an infinite number of solutions or just two solutions, anything more than one, the expectation is that you check one of the two equations, or one of the two solutions. The expectation is also that you check the most unusual one. So we're assuming that if you can arrive at the most unusual answer and have gotten it right, then the assumption is you could have gotten the other ones right as well. So in this case, between negative 4 and 1, the unusual one, quote, so to speak, is negative 4. So negative 4 squared plus 3 times negative 4 minus 4 is equal to 0. 16 plus negative 12 minus 4 is equal to 0. That's obviously true, so there's a check in that case. That's good enough to have checked it. Just need to use one of the two solutions that you ended up with in that particular case. An expression, you don't end up with solutions. An expression means you don't have an equal sign. There's no solutions. You know, I've had students in the past that try to tell me, you know, x is something here. X is negative 4/3 or who knows what. Students try to, this isn't solvable. This is an expression. An expression comes from the idea or the directions to simplify. So if we're going to simplify, there's nothing actually here to simplify at this particular point. So what I do is I'm going to change this into that. Now something can be simplified. Again, there's no equation. X doesn't equal anything. All I'm doing is simplifying, which means changing the form from one form to another. Those are supposed to be called equivalent expressions. And what that means is whatever value for x, and by the way, I don't know what x is, but whatever value for x gets put in here gives you a particular number, but it doesn't say which x it is. There's an infinite number of choices. I can plug in pi, I can plug in a negative 1,000, I can plug in all kinds of things. So this expression, when I simplify it, should be equal to or should give me the same answer than an expression later. So I'm going to take advantage of that situation. First of all, let's simplify this. So let's say this is negative x squared minus 2x minus 3. We distribute the negative through there, so that's 3x plus 4 is equal to that. Negative x squared doesn't have anything that goes with it, or you can actually say that as the opposite of x squared. 3x minus 2x is x. 4 minus 3 is 1. So there's the simplified form, and it is the answer because it's what is simplified, so it gets circled. But then the question is, how do I check and know if this is right? I mean, let's do just guess in the dark. Is there a way to know if this is right or not? Yes. Whatever x that would be that you would plug into the original should be able to be plugged into this one, and you should be able to get the same value. If the values are different, you're definitely made a mistake. If the values are the same, you're probably right, and I'll explain why that is in just a second. So how do I check this? You do not use 0, we do not use 1, we do not use 2. Everything else is fair game. 0.5, pi, 77, negative 83, doesn't matter. My tendency is I try to use 3s. 2s are okay if there's more than one variable. If there's only one variable, use a 3 or use something else. 5, 4, something else. So what I do is I take this 3 and I plug it in and I see what I get. And yes, you can do this work on a calculator, and that's usually what I'll do. So that's going to be, but I'm going to need to do that work here. So 3 times 3 is going to be 9 plus 4 minus 9 plus 6 plus 3. So that's 5, no, not 5, 13 minus 15, 18. This gives me negative 5. When a 3 is plugged into this expression, I end up with negative 5. If I've done my work correctly and brought this down correctly, I should be able to get the same value out. So when I plug a 3 in here, that gives me negative 9 plus 3 plus 1, which does turn out to be negative 5. So what I did is I plugged it into the original, I record the number that I ended up using, so that number gets recorded, and then the check tells me that it was plugged into the other piece as well, and the values turned out to be the same. And so therefore what I did was correct. Now let me show you what happens if I made a mistake. Let's say I made this mistake. Let's say I forgot to put the negative on the x squared when I came down here. So when I go to plug the 3 in this time, this will be positive 9 plus 3 plus 1. That's 13. That's not the same as the negative 5, so I know a mistake has been made. Now I mentioned a couple minutes ago that it's probable that my answer is correct. Now let me show you, with numbers, there's a possibility some weird things could happen. So let's just give you an easy one. So let's say I had x plus x, and I said that was x squared. Well, if I plug in a 2, 2 plus 2 is 4, 2 squared is also 4, it looks like what I've done there is correct. So it's possible that you could choose just the right number that makes something look like it's correct when it actually isn't. If the numbers are different, you definitely have a problem. It might have been you plugged it in wrong on the check, or it could be some other things. Do not lie to me about the checks. If this is not a correct answer, I'll know from this number whether or not this could have happened. But what if I chose a different number? Let's say I plugged in 5 instead. 5 plus 5 is 10. 5 squared is 25. Because those don't match, I know that I've made a mistake. So there's possible that based on the numbers that are going on there, you could choose just the right number to plug in and end up with something that seems like it's correct and maybe not. But that's still good enough for you. The biggest thing is when you're working on a problem like this, if you have a check fail and this is a test, tell me it fails. Because you've probably made a silly mistake in here somewhere. Don't take the time on the test trying to find it unless you have time to be able to come back to it and let me know, hey, this didn't fail. If you tell me a check worked when a check couldn't have worked because of the value that was plugged in there, then you're going to lose all the credit for that particular question if it's a test. All right, so that's the checking process. If you have any questions, particularly have any questions about dealing with the expression version of doing this, be happy to show you how to do that. Until next time, see ya.